We've just found a pimpleback, but it's not very pimply on its back, and part of the issue, and this can make identifications difficult and other practical problems, but it's also an interesting observation in that not just the species differ according to the water flow, but individuals within a species might look different in different locations. Is that fair to say?
Yeah, I think that is fair to say, and one of the areas where we've been observing that is through some of the propagation facilities in the U.S., where they're set up to rear endangered species, for example, for reestablishment in areas, but they've been observing in some species that when they're reared in captivity without the physical forcing factors that they would experience in the river, the shells look very different than what they would look like in their native river. So I don't think at this point we're totally clear on why that is, like what the actual mechanism is, but certainly there appears to be an element of a necessity for that physical environment to lead to the proper.
Right, so that might even actually not reflect genetic variability so much as a phenotypic plasticity, where the same genotype can lead to different phenotypes according to the developmental environment.
Yeah, I think that's very true. I think there's probably an element of both. For example, in the maple leaf, which is a close relative of this species, we see the maple leaf population in the lower Grand River has a very characteristic distribution of pustules, 2 rows extending from the beak down. But if we go just over to the Welland River, we see that the pattern of pustules is very, very different. Although it's consistent within the rivers, it's different across the rivers. So there probably is a genetic element to that as well, and then undoubtedly there's a physical.
And do those rivers differ greatly in properties, or are they relatively similar?
Yeah, no, they certainly do. The Grand is a large river system flowing water, whereas the Welland is a much lower gradient system. It's not a typical system actually where you would expect to find a lower river species with pustules, being a low energy system, but they are there, and historically we know they've been there for at least 100 years, and the patterns are just very different between the two. So some of it may be physical, some of it may be genetic.
Yeah, and those things tend to interact. I mean, there might be genetic differences in the range of phenotypes that you're able to do, the reaction norm. And so, yeah, it's always going to be a combination of environment and genetics, and this is a very good example of that.